This is the video for lesson 9.3 and 9.4, where we are going to learn about two new transformations. We're going to learn about reflection, and we're also going to be learning about rotation. So if you could please fill in the vocabulary terms here. A reflection is a transformation that uses a line like a mirror to reflect an image. That line that we use is called a line of reflection, and that's the one that acts like a mirror, and we're going to use it like a mirror to reflect an image over that particular line. And then with rotation, this is generally the one that most students think is the trickiest, and so you're going to have to pay close attention to how we do the rotation. Rotation is a transformation in which a figure is turned about a fixed point, and we're going to use the origin on the coordinate plane as our fixed point, the origin. So that's the center of rotation. That's the fixed point in which a figure is turned about. So we're going to be talking about the four quadrants of the coordinate plane, and this is something that you should remember back from Algebra 1. So we'll review the four quadrants, and we're going to rotate some figures around the origin. Theorem 2, reflection theorem, just states that reflection is an isometry. I just want to remind you that this preserves size and shape. So the size and the shape of the figure does not change in an isometry. So reflection is isometry, rotation is isometry, so no size or shape should be changed. The figure should remain the same figure, just moved to a new spot on the coordinate plane. So there are two directions that rotations can take place. Clockwise, which if you remember, clockwise is going in this direction, and counterclockwise is going in the opposite direction. So that would be this way. Alright, if you are asked to rotate a figure, if no direction is given, if it doesn't say you need to rotate it clockwise or counterclockwise, then you're going to assume that the rotation is counterclockwise, which seems a little bit odd sometimes. I think students want it to be clockwise, but if no direction is given, then remember it's going to be counterclockwise. And a lot of times I will abbreviate that with CCW for counterclockwise. Alright, well, let's go ahead and get started with some practice problems here, some example problems. We are going to reflect this figure, ABCD, over the line y equals x. So here's our line of reflection right here. Okay, this is the line called y equals x. It's got positive slope, it goes straight through the origin, and that's the name of that line. So we have to remember that this is called the pre-image figure. So this is our original figure, and we are going to reflect it over this line. So the way that we do that is we count the number of spaces to the line of reflection, count to the line, and then go down the same number. The same number of units. So when we count over to the line, I'm just going to use a highlighter here. So let's just start with point A. We need to count the number of spaces over to the line of reflection. And if I count correctly, that's 6 spaces. And then from that point, I'm going to turn and I'm going to go down the same number of spaces. So I've arrived at this point right here. And again, this was 6 spaces going down. So from the original point A, I've now got my point A prime. And I have to do that with each of these points. So I'm going to count over from B to the line of reflection. That was a total of 2 spaces. And now I'm going to go down the same number of points, and I'm going to plot my point B prime. I'm going to do that for points C and D also. I have to count over to the line of reflection. Remember to go all the way to the line. So there were 4 units there. And I'm going to go 4 units down this way. And then I have to do that for point D as well. I'm going to count all the way over. There were 8 units away from the line of reflection, and now I'm going to plot point D prime there as well. Alright, so now I have my image A prime, B prime, C prime, and D prime. I just want to remind you that the yellow lines here are just me counting the number of spaces over to the line of reflection. You don't have to put those in there. I'm just showing you what I'm doing. But you do need to plot the 4 points and also connect those dots. Just a reminder that the line of reflection should be like a mirror. So our original image and our new image should be the exact same, but just reflected if there was a mirror at the pink line there. Alright, we're going to try another one. This time we're going to use the line y equals negative x. And with that negative being there, the slope is negative, so that's why the line of reflection is going straight through the origin, but it is going in a negative direction. So our pre-image is this trapezoid right here, and we need to reflect it over the line of reflection. So if I take my very first point and I'm going to count the number of units over to the line of reflection, remember we have to go all the way to the line of reflection. In this case we have 7 units, so now I have to go 7 units down. There's 3, there's 4, and that's where I'm going to plot my point R prime. Okay, so please do that for each point. Alright, so I have done T prime, R prime, A prime, and P prime. Notice that P prime is on the line of reflection because that original point P was on the line of reflection as well. So we did not have to count any number of units over to the line because it was on the line. So for T, I counted over to the left 4, so I went down 4 for T prime. And same thing for A prime, I counted over 6 spaces. So just notice that the blue figure here is the exact same shape as our pre-image, but just reflected over that line called y equals negative x. Okay, on the back of that first page, I would like you to take a look at some other reflecting problems that we're going to be doing. So if we have this image A, B, C, D, the pre-image, and we're going to reflect over the y-axis. And remember, this is the y-axis. So we're going to take all of our points, count to the y-axis, and then plot a new point on the other side the same distance away. So if I start with my point A, I count 2 units to the y-axis, and then I need to go 2 units past the y-axis and plot my point A prime. Again, I'm going to count from B to the y-axis. That was 1 unit. I'm going to count 1 unit past there, plot my point B prime. And then the last one, of course, is C. I went 1 unit to the blue line, or the y-axis. Now I'm going to plot my third point, C prime. And then when I connect those, they should come out to the exact same figure. It's just that that blue line cuts those two figures right in half. So we're exactly the same distance away from the y-axis from all of those points. So I want you to write down a rule, because we're going to be reflecting over the y-axis several times in the problems that you're going to be doing. The rule is to change the sign of the x value. So if you notice what happened here, when we reflect over the y-axis, the sign of the x value changed because the point A is still 4, but now it's negative 4 over here. Alright, and B was at x is 2, but now in our new image, x is negative 2. So what we're saying is change the sign of the y value, change the sign of the x value. The y value remains the same. We didn't change how far up or down that figure moved. It just reflected over the y-axis. Alright, now we're going to try that same thing, but we're going to use the x-axis. So remember, this is our x-axis, and so if they're asking us to reflect over that line, we need to count the number of units from the point to the line and then continue past the line the same number of units. So I'm going to plot my A prime right here. Number of units to the line from B is 3, so I need to go past that line 3 units. Plot my point. Most students find that this type of work is the easiest in terms of all of the transformations that we've been doing. Here's 2 units, so I'm going to go 2 units past there, plot my C prime point, and then connect. And if you notice, the black figure, which is our pre-image, and the purple figure, which is our image, that blue line, our line of reflection, cuts right in between, or cuts those things right in half. So all we did is we changed our y values. So the rule for reflecting over the y-axis is change the sign of the y value. So changing the sign means that we had a positive value for A here, but it's negative for the reflected point, right? We had a negative value for y for point B, but now it's a positive value for y. So the rule is just to change the sign of the y value if you're using the x-axis as your line of reflection. Okay, a couple more that we're trying over some different lines of reflection. This time we're going to use y equals -2 as our line of reflection. Now a lot of students have a hard time remembering that y equals -2 is this line right here that goes straight through -2 on the y-axis. Okay, so this is our y-axis, and therefore the horizontal line, this is going to be a horizontal line through y equals -2. And we're going to do the same exact thing, count the number of units to that line of reflection, and plot another point 2 units away from the line of reflection because B was 2 units away. So here's my B prime. So I'm going to do the same thing with all my points and get my new image. Okay, C was on the line of reflection, so therefore C prime is also going to be on the line of reflection. The purple figure is the new image, and it's because the points there are the same number of units away from the line of reflection as the original point. So you should not see any change in size or shape, but just now relocated into a new space on the coordinate plane. So in the next one over to the right, we're going to use x equals 2, and that line is this line right here. So every place that x is 2 is the line of reflection that we're going to be using, and this one is a vertical line. So a lot of students again forget that that's the x equals 2 line. They think that it goes horizontally, but anytime you see x equals, it's going to be a vertical line. So what I have to do is I have to count the number of units to that line. So from B I went 1 unit. I'm going to plot my B prime right here because it's 1 unit away, but on the other side of that blue line. Same thing for the other 2 points. Again, when you get finished, the new figure should look the exact same. It's just now reflected over that line that you used as a mirror. Remember, the blue line is like a mirror, so you should see the exact same figure, just on the other side of the line. So the last thing that we have here on this page is to come up with what is the line of reflection. If we have this original figure, the dashed line is the original figure, now I have it in purple, and we have a new figure down here, what line was used as a line of reflection? Well, you can find C and C prime and take half of the number of units, and that's where that line of reflection is going to take place. So we have 2 units between C prime and C, and how many units do we have between B and B prime? If we count those up, I think that looks like 8. So if we take half of that, that would be 4, which would be right here, and half of the units between C and C prime would be just 1 unit. So the 2 purple dots, if I connect those, we can see that's going to be our line of reflection because it's halfway between the points that we have. B and B prime, halfway was right here, and halfway between C and C prime was right there. So that's all you have to do is find the number of units. So in the next figure, how many units are between B and B prime? Looks like 4. So halfway would be 2, right? And that makes sense because look at where C and C prime is. Those two are right on the y-axis. So it looks like they use the y-axis as the line of reflection. So we're going to have to write what the name of that line of reflection is as well. This one, the first one, was y equals -2. Remember, horizontal lines are the y equals type lines. This one is just the y-axis. So not only draw in the line, but also name the line. And then we have an interesting one over here. How many units away from A is A prime? Well, looks like we had to go over and down there. Same thing with C, right? C and C prime. So if we connect those points where the line turns, that goes straight through the origin, and this line of reflection is going to be y equals x. And we did have an example of each type of problem as we've described here in terms of the line of reflection.